Good morning children. In this video, we are going to discuss about characteristics of hydrocarbons followed by test to identify saturated and unsaturated compounds. The next one, classification of organic compounds based on functional group. Finally, about homologous series and its characteristic features of homologous series, and the last one, nomenclature of organic compounds. These things we are going to discuss in this video. Right. So in the last class we discussed about hydrocarbons, isn't it? What is meant by hydrocarbons? Hydrocarbon is an organic compound which is composed only of hydrogen and carbon atoms, isn't it? So hydrocarbon is a naturally occurring carbon, isn't it? Naturally occurring organic compound. So hydrocarbons have some special characteristic features. What are they? Let me see one by one. First point, lower hydrocarbons are gases. You know about hydrocarbons. Hydrocarbon is composed of only carbon and hydrogen atoms. Then what is meant by lower hydrocarbons? If the carbon atom is low. For example, if you take methane, its formula is CH4. Okay. How many carbon atoms are present here? Only one carbon atom. So methane is a lower hydrocarbon. Okay. Next one, ethane. How many carbon atoms are present? What is the formula of ethane? C2H6. That is 2 carbon atoms and 6 hydrogen atoms are present. So 2 carbon atoms are present. Hence it will also come under the category of lower hydrocarbons. Okay. So if the carbon atom which comes below 4, then we can say those things will come under lower hydrocarbons. Okay. So lower hydrocarbons are all are gases. Okay. For example, methane, ethane are gases only. Okay. What is the first point? The first point is lower hydrocarbons are gases. Example, methane, ethane. Right children? Okay, second point, hydrocarbons are colorless and odorless. Okay, hydrocarbons are colorless and odorless. So hydrocarbons have no color and also it has no smell. Okay, odor means smell. No color as well as no smell. That is the second point. And third point, boiling point, that is hydrocarbon. Okay, the hydrocarbons boiling point increases. Boiling point of hydrocarbons increases with increase in number of carbon atoms. Okay, so boiling point of hydrocarbon increases with increasing number of carbon atoms because larger molecules have more number of electrons. So, if you increase the carbon atom, then automatically the boiling point of hydrocarbon increases. Okay, that is the concept behind this. The boiling point of hydrocarbons increases with increasing number of carbon atoms. Got it? Right. Next one, hydrocarbons undergo conversion reaction with oxygen to form carbon dioxide and water. Okay. So hydrocarbons, when it reacts with oxygen, to form carbon dioxide and water. Okay. Because it is a combustion reaction. Combustion means burning. So along with this carbon dioxide and water, heat is also produced. Why? Because it is a combustion reaction. Got it? Hydrocarbons, when it reacts with oxygen to form carbon dioxide and water, along with that heat is also produced. Got it? Right. Next one, alkanes are least reactive. What is the reason behind this? Why alkanes are least reactive? Already in the previous video we saw about alkanes. It is saturated hydrocarbon. Saturated hydrocarbon single bond. Okay, that is why alkanes are least reactive in nature. This alkane is a hydrocarbon. Okay. Next point, alkynes are most reactive. What is the reason behind this? Why alkynes are most reactive? Because already I told you, alkynes are unsaturated hydrocarbon. Alkenes as well as alkynes are unsaturated hydrocarbon. Here for alkynes, the carbon atoms are connected by triple bond. That is why alkynes are most reactive in nature, whereas alkanes are less reactive. Why? Because carbon atom is connected by single bond. Okay, single bond means less reactive in nature, whereas double bond or if triple bond means more reactive in nature. Double bond means little bit high reactive in nature, but triple bond means it is highly reactive in nature. Got it, children? Right. Next point, alkanes are saturated, whereas alkynes and alkenes are unsaturated. Alkanes are saturated compound. Why? Because here the carbon atoms are connected by a single bond, whereas alkenes and alkynes are unsaturated. Here the carbon atoms are connected by, for alkenes, double bond, whereas for alkynes, triple bond. Got it, children? Right. Next point is hydrocarbons are insoluble in water. It will not soluble in water. You might have heard about this. Like dissolves like. Okay. Like dissolves like. What is the meaning for this? For example, polar solvents dissolve in polar solute quantity, whereas non-polar solvents dissolve in non-polar solute. Okay. Water is a polar solvent, whereas hydrocarbon is a non-polar. That is why it is insoluble in water. Okay. So hydrocarbons are insoluble in water. Once again we can see it's also very important 5-mark question. Characteristics of hydrocarbons. First one, lower hydrocarbons are gases. Example, methane and ethane. You should write the name also. Along with that you have to write the formula. Okay. Second point, hydrocarbons are colorless and odorless in nature. It has no color and also it has no smell. Next one, hydrocarbon. The boiling point of hydrocarbon increases with increasing number of carbon atoms. Next one, hydrocarbons, when it reacts with oxygen to form carbon dioxide and water, also heat is liberated. Why? Because it is a combustion reaction. Combustion means burning. Got it? Right. Next one, alkanes are least reactive in nature because here the carbon atoms are connected by single bond. Alkynes are most reactive in nature because the carbon atoms are connected by triple bond. Okay. Next one, alkanes are saturated, whereas alkenes and alkynes are unsaturated. You know the meaning, because alkanes are connected by single bond, alkenes are connected by double bond, whereas alkynes are connected by triple bond. And the last point is hydrocarbons are insoluble in water. Got it, children? Any doubt in this? Okay, shall we move to the next one? Good. Second one, we can discuss about test to identify saturated and unsaturated hydrocarbons. Okay. Test to identify whether the given compound is a saturated compound or unsaturated compound. For this test, bromine water test is mainly used to differentiate the saturated hydrocarbon as well as unsaturated hydrocarbon. Bromine is a reddish brown liquid. Okay, bromine is a reddish brown liquid, and it is soluble in water. Okay, it is soluble in water, and its aqueous solution is called the bromine water. Okay, bromine is highly corrosive, and also its vapors are highly toxic in nature. Right? It directly affects the thyroid gland as well as nervous system. So we should handle the bromine with utmost care in the laboratory. Got it, children? Right. So bromine water test. Okay, some steps we have to follow. What is the first step? The first step is take the given sample solution in a test tube. Take a test tube. Given sample solution will be given to you. That sample solution you have to take it in the test tube. That is the first point, right? Second point, you have to add the bromine water in dropwise. Okay, in dropwise you have to add the bromine water, and you should observe the any changes is coming, any changes in the color. You should observe the changes in the color. Okay, this is the second point. Third point, if the given sample is unsaturated, okay, if the given sample is unsaturated, it will decolorize the bromine water. Okay, if the given sample is unsaturated, it will decolorize the bromine water. Whereas if the given compound is saturated, it will not decolorize the bromine water. So what do you understand from this test? Okay, from this test we can identify if the given sample is alkene, that is bromine water reacts with alkene, and also color will change, that is it decolorize the bromine water. At the same time, if the given sample is saturated, that is alkane, it will not, the bromine water will not react with alkane, and the color also will not change. This is the concept behind this. Okay, once again I will tell you, given sample will be given to you. From that sample you have to identify whether it is a saturated compound or unsaturated compound. Saturated compound means you know it is an alkane. Unsaturated compound means it may be alkene or alkyne. Okay, first the sample is taken in a test tube. Next we have to add the bromine water in dropwise, and you have to observe any changes in the color. Okay, suppose if the given sample is unsaturated means it will decolorize immediately the bromine water. So you can easily understand it is the given sample is an unsaturated compound. Suppose if the given sample is saturated compound means the bromine water will not decolorize, it will not react. Okay, alkanes do not react with bromine water, whereas bromine water it decolorize the alkene, and as well as alkynes it reacts with the bromine water. Got it, children? So this is the concept. From this we can identify whether the given sample is a saturated compound or unsaturated compound, right? Next one. Next we can move to classification of organic compounds based on functional group. Okay, classification of organic compounds based on functional group. Actually, the network of the given sample, okay, is framed by carbon as well as hydrogen atom. That is the structural arrangement. You can say the structural arrangement. The structural arrangement of the organic compounds are made of carbon and hydrogen, and these carbon and hydrogen make the organic compound less reactive in nature. At the same time, some atoms or group of atoms makes the compound more reactive. Okay, makes the compound more reactive. And these compounds, these atoms or group of atoms decides the chemical properties of that organic compound. Okay, so these groups are called the functional groups. Okay, once again I will tell you, the structural arrangement of organic compounds are made of carbon and hydrogen. It is less reactive in nature. At the same time, some atoms or group of atoms makes that organic compound highly reactive, and it decides the general chemical properties of the organic compound. So these are called the functional groups. Okay, so what is meant by functional group? Atoms or group of atoms makes the organic compound. Okay, makes the general properties of the organic compound are called the functional groups. Okay, so just to look at this table classes of organic compounds based on functional group. Okay, what are the various functional groups that those things we can discuss now. First one, class of the compound is given, functional group is given, common formula is given, as well as examples also given. First compound is alcohol. Okay, compound name is alcohols. Its functional group is bond OH. This is nothing but bond. Okay, bond OH. So this is one of the functional group. I told you, no, atoms or group of atoms makes the compound more highly reactive. Okay, these compounds only decides the general properties of the organic compound. So this OH is also nothing but the functional group. Okay, so OH means it mentions the alcohol. Got it, children? Right. The common formula of alcohol is ROH. Okay, ROH. Yeah, this one is bond already I told you. ROH. Leaving this functional group. Okay, leaving this functional group, the rest of the compound is mentioned as R. Okay, leaving this functional group, the rest of the compound is mentioned or explained as R. So, the common formula of alcohol is ROH. Okay, for example, ethanol, that is ethyl alcohol, otherwise we can say ethyl alcohol, and its formula is CH3CH2OH, or otherwise we can say C2H5OH. Both are same only. How many carbon atom? 2 carbon atom, 6 hydrogen atom and 1 oxygen atom. Like that we have to calculate. Okay. So once again I will tell you, compound is alcohol. Class of the compound is alcohol. Its functional group is bond OH. Common formula is ROH. Example is ethanol. Its formula is CH3CH2OH, or we can write C2H5OH. That is ethyl alcohol. Example of alcohol. Okay. Second one, aldehydes. Second one is aldehyde. This is a compound. Functional group of aldehyde is CH double bond. This one is double bond. Okay. O. CHO. C is carbon atom, H is hydrogen atom, and this is oxygen atom. Okay. So CHO, aldehyde. Its functional group is CHO. Here double bond will come, and the common formula is R bond CHO. Okay. Leaving this functional group, the remaining is mentioned as R. Okay. R CHO. Example is acetaldehyde. Example is acetaldehyde, and its formula is CH3CHO. Okay. Example is acetaldehyde. Its formula is CH3CHO. Third one is ketones. Third one is ketones. Its functional group is CO. Double bond will come here. Okay. Its functional group is CO. Common formula is RCOR. Okay. RCOR. And its example is acetone. Example is acetone. Its formula is CH3COCH. What is coming here? Functional group is coming, isn't it? Here CHO is the functional group. Here OH is the functional group. Got it? Right. Next one, carboxylic acids. Next one is carboxylic acids. Its functional group is COOH. Double bond will come here. Okay. COOH, and its common formula is RCOOH. Okay. RCOOH, and its example is acetic acid. Vinegar contains acetic acid. Okay. Vinegar is mainly used as a preservative for making pickles, isn't it? So vinegar contains acetic acid. Example is acetic acid, and its formula is CH3COOH. Okay, CH3COOH. Next one is ester. Okay, name of the compound is ester. Its functional group is COOR. What's the functional group of ester? COOR. Example, methyl acetate or methyl acetate, and its formula is CH3COO-CH3. CH3COO-CH3. Got it? Right. Next one, ether. Last one is ether. OR. Okay, bond OR, and its common formula is ROR. Example is dimethyl ether. Dimethyl ether, and its formula is CH3OCH3. These things will come under one more question, children. So you have to learn the compound, okay, and its functional group, its general formula, common formula, and also examples also you have to give. For each and every example, you have to mention the structure also, the common formula also you have to write for each and every compound. Okay, so these things you can expect in the 1 mark question. Got it, children? Okay, children. Next we can move to homologous series. Okay, homologous series. What is meant by homologous series? A homologous series is a group of organic compounds which contain same general formula, similar chemical properties, and also the consecutive members differ by CH2 group. These are called the homologous series. Okay, once again I repeat. Homologous series is a group of organic compounds which contain same general formula, similar chemical properties, and also the consecutive members. Consecutive members means successive members. Next coming members, they differ by CH2 group. Okay, CH2 means methylene group. Got it, children? So these are called the homologous series. Okay, look at this one. This is alkane. Okay, what are the examples we saw for alkanes? Methane, ethane, propane, butane, pentane. Okay, 5 examples we saw already. First one, if you take this methane, what is the formula of methane? CH4. Next one, ethane formula C2H6. Okay, if you take this methane and ethane, okay, what is the difference between the carbon atom? There is a difference of 1 carbon atom. If you take these two, methane and ethane, there is a difference of 1 carbon atom, and also there is a difference of 2 hydrogen atoms, isn't it? Okay, so now CH2. If you take these two, ethane and propane, there is a difference of again 1 carbon atom, and there is a difference of 2 hydrogen atoms, CH2. Okay, you can take these two, C4H10 and C5H12. There is a difference of 1 carbon atom, and there is a difference of 2 hydrogen atoms, CH2. So the consecutive members, the successive members, the next coming members differ by this CH2 group. These are the homologous series. Okay, CH2 means methylene group. Okay, methylene group. Next we can see alkene. Not only for alkene, this is applicable for alkenes as well as for alkynes. Got it? Next we can see these two. We can take these two, ethene and propane. Okay, ethene and propane. There is a difference of 1 carbon atom, and there is a difference of 2 hydrogen atoms, isn't it? CH2. We can take these two, C3H6 and C4H8. There is a difference of how many carbon atom? Only 1 carbon atom, and difference of 2 hydrogen atom. Take these two. There is a difference of 1 carbon atom and difference of 2 hydrogen atom. Okay, so this is the CH2 group. Next we can see alkyne. Ethane, propane, butane, pentane. Okay, we can take these two. There is a difference of 1 carbon atom, and there is a difference of 2 hydrogen atom. You can take this last two, difference of 1 carbon atom and difference of 2 hydrogen atom. Okay, so a homologous series is a group of organic compounds made of, what is the homologous series? Is a group CH2 group. That CH2 is nothing but methylene group. Got it? Okay. Homologous series have some specific general characteristics. What are the general properties of homologous series? Let me see now. First one, each member. Member means what? These are the members: methane, ethane, propane, butane, pentane, ethane, propane, butane, pentane. These are nothing but members. Homologous series members. Okay. So each member differs from preceding or succeeding member. Preceding or succeeding. Okay. Preceding means this one. Succeeding means this one. The next one. Member by one methylene group, that is CH2. This is one of the characteristic feature of homologous series. Second one, all members contain the same elements and also functional group. Okay, all the member contain the same element. Okay, carbon element or hydrogen element, and also contains the same functional group. Next one. Homologous series general molecular formula. Example alkanes, that already we have discussed about alkanes. Okay, the general formula of alkane is CnH2n plus 2. Okay, it has, that is homologous series has general molecular formula. Example alkane, and its formula is CnH2n. Next one. Chemical properties of the member are similar. Okay, all the chemical properties of these members are similar in nature. Next one, homologous series can be prepared by common method. General method of preparation is common only for the homologous series. These are the general characteristic features of homologous series. Okay. Next we can discuss about nomenclature of organic compounds. What is meant by nomenclature? Nomenclature means naming things. Okay, nomenclature means naming things. In olden days, the name of the organic compounds were based on the natural things from which they were obtained. Okay, after that, organic compounds were produced or synthesized from different sources other than natural sources. So, scientists, they framed a systematic method of naming the organic compounds by using their structures, based on their structures. Okay. So, a set of rules was formulated for naming the organic compound by IUPAC. IUPAC in the sense International Union of Pure and Applied Chemistry. Okay. So in this we are going to learn about the nomenclature of organic compounds. How to name the organic compounds by using the IUPAC. Okay. IUPAC means International Union of Pure and Applied Chemistry. Okay. So what are the components of an IUPAC name? Three components are. It is divided into three parts. Okay, these three parts are very important for naming the organic compound. One is the root word, second one is the prefix, and third one is the suffix. Okay, root word, prefix, suffix. These three parts combine to get the IUPAC name. Okay, these three parts are very important for naming the organic compound. One is root word, second one is prefix, and finally suffix. So, prefix plus root word plus suffix all together give the IUPAC name. Okay, so this is also very important. Without these three, you cannot name the compound. Okay, so these three things are very important. One is root word, second one is prefix, and third one is suffix. Okay, so first let me discuss about the root word. Root word gives the number of carbon atoms which are present in the parent chain of that particular compound. Okay, root word tells the or gives the number of carbon atoms which are present in the parent chain of the compound. So look at this tabular column. Number of carbon atoms as well as root word is given. Here for some root words we are using Greek numeral. Okay. So first 2, then we have to use the root word eth, E-T-H, eth. Okay. For 3 carbon atoms, if carbon atoms are 3, then we have to use the root word prop, P-R-O-P, prop. Next one, 4 carbon atoms means but. Don't say but, but, B-U-T. Next one, if carbon atoms are 5, then we have to use the root word pent, P-E-N-T, pent. If 7, then hept. If 8, oct. 9, non. 10, dead. So these are very important. Without knowing this tabular column, you cannot name the organic compound. So you should learn all this one. Okay. The number of carbon atoms you should learn. Along with that, you have to learn the common word, that is root word of that particular carbon atom. So this is very important. Met, eth, prop, but, pen, hex, hep, oct, non, dead. So these are the root words. The root words tells the number of carbon atoms which are present in the parent chain of the compound. Okay, got it? Clear, children? Shall we move to the next one? Good. Next we can move to the prefix. Okay. The prefix, it represents or it explains the substituents. Substituents in the sense branch or group, we can say like that. Okay. So the prefix explains the substituents. Atoms are group of atoms other than hydrogen. Okay. Atoms are group of atoms other than hydrogen connected by the carbon atoms of the parent chain are called the substituents. Okay. So what are the various substituents and what are the prefix we have to use? Let us see now. Look at this tabular column. Bond F. Okay. F, the substituent is F. Then what's the prefix we have to use here? Fluoro. For F we have to use fluoro. For Cl, substituent is Cl. Then the prefix chloro has to be used. Next, suffix Br. Here the prefix, substituent Br and the prefix bromo has to be used. Next, for I, prefix iodo. Next, substituent NH2. This one is bond. Okay. Substituent bond NH2. The prefix used is amino. Amino. Okay. Next, the substituent is CH3. Bond CH3. And the prefix used is methyl. Okay. Fluoro, methyl or methyl. We can say methyl. Okay. Fluoro, chloro, bromo, iodo, amino and methyl. So you have to learn the substituents also, then only we can give the prefix along like this. Okay. So prefix tells it explains the substituents or groups or branch. Got it? Right. Next we can move to the suffix. Okay. You know very well the suffix gives the end of the name, isn't it? The suffix gives the end of the name. Suffix, there are two parts of suffix. One is the primary suffix and another one is the secondary suffix. Okay. Primary suffix as well as secondary suffix. The primary suffix comes after the root word. Okay. So the primary suffix comes after the root word. Okay. And also this primary suffix I told you it mentions the carbon to carbon bond of the parent chain. Okay. Primary suffix tells the carbon to carbon bond of the parent chain. Right. If all the bonds in the carbon atoms are single, then suffix A has to be used. A means A-N-E. For alkane we are using the suffix A-N-E. So, if all the bonds between the carbon atoms are single, then suffix A has to be used. At the same time, if all the bonds between the carbon atoms are double, then suffix E has to be used. If all the bonds between the carbon atoms are triple, then the suffix "ine" Y-N-E has to be used. Okay, A-N-E for single bond means A-N-E, for double bond E-N-E, and for triple bond Y-N-E. Okay, A-E as well as "ine." Mainly it focuses, the suffix focuses the functional group of the compound. Got it, children? Right? Okay. So next one, see suffix for IUPAC name. Okay. Class of the compound is given. Functional group is given. Suffix used. First one, alcohols. Okay, alcohols. And the functional group is bond OH. Suffix used is bond OL. Alcohol OL. Okay. Next one for aldehydes. Functional group is bond CHO and the suffix used is al, bond Al. Next one for ketones, its functional group is C double bond O. Okay, and its suffix used is O. Next one, carboxylic acid, its functional group is bond COOH and the suffix used is oic acid. Okay, suffix used is oic acid. So these tabular columns are very important. Each and everything you have to learn, children. For prefix, suffix, as well as root word, everything you have to learn. Okay, no other way. Mostly you will be getting 1 mark question or 2 mark question in this category. Okay, so these things are very important. Okay, next we have to follow some set of rules for naming the organic compounds. Okay, what are the rules? First one, we have to, as per rule 1, we have to count the number of carbon atoms of the parent chain in that particular compound. Okay, a compound will be given to you. First, what we have to do? We have to count the number of carbon atoms. So this is the first rule. Okay. Next one, we have to give the numbers. Okay, we have to give the numbers. So these numbers are called the locant numbers. Okay, these numbers are called locant numbers. If both the substituents as well as functional groups are present in a compound, then we have to give preference for the functional group. This is rule 1. Got it? First, we have to count the number of carbon atoms in the parent chain of that compound. Next, we have to give the number. That number is called lowest possible number we have to give. That number is called the locant number. In a particular compound, both substituents as well as functional groups are present, then we have to give preference for the functional group. Okay, so this is the first one, right? So next, what we have to do? We have to, already told you, we have to give the number, right? Next one, identify. Okay, identify the double bond as well as triple bond. Identify the double bond or triple bond, and also you have to identify whether the given bond is single. Okay, whether the given bond is single, then we have to use ane. Suffix just now I told you, no. Next, what we have to do? Identify the double bond or triple bond. Okay, and we have to give the locant number for this, and then put one hyphen. That is put one hyphen. Okay, dash. Hyphen means put one dash, and primary suffix has to be written. Okay, put one dash and primary suffix has to be written. Okay, if the group contains a functional group, okay, if the organic compound contains functional group, then number has to be given, token number has to be given, followed by a dash and a secondary suffix has to be given. Okay, next one. If the both, that is primary suffix as well as secondary suffix are coming, in that case, at the end of in the primary suffix as well as secondary suffix we are putting no. In the end, the terminal E of the secondary suffix has to be removed from that. Okay. Some examples we can see, that time I will tell you in detail. Okay. In the next video we will see about, once again we will see about the rules. Okay. Okay. So the terminal E has to be removed. Next we have to identify the last one, we have to identify the substituents. As usual we have to put the locant number. Okay, and also followed by a dash and a prefix to find its location. Okay, we have to find the location. We have to know the identity. Then only we can know the identity. So these are some of the rules. Okay. In the next video we will see about clearly we will see about the rules and also some examples we can see. In this video we can see only one example based on this rule. Okay. First one, compound is given to you. Okay, the compound is given to you. We have to give the IUPAC name of this particular compound. That only we are going to do now. So what is the compound? CH3 bond CH2 bond CH2 bond CH2 bond CH3. So this compound is given. We have to give the IUPAC name of this compound. So first thing what we have to do, as per rule 1, we have to find out the number of carbon atoms in the parent chain. Okay. First of all, we have to identify the longest chain of the carbon compound. Okay. This point is also very important. As per rule 1, we have to find out the longest chain of the carbon atom. Okay, next we have to identify how many carbon atoms are present. Okay, so in this carbon atom, as per rule 1, what we have to do? We have to find out the longest chain of the carbon atom. We have to count the carbon atom. Okay, so how many carbon atoms are present here? 1, 2, 3, 4, 5. 5 carbon atoms are present, isn't it? Okay, what's the step 1? It is a 5 carbon chain and the root word is pent. See the root word. If 5 carbon atom means what we have to do? We have to write the root word pent. Okay. So here 5 carbon atoms are present. So we have to write the root word pent. Got it clear, children? First point. As per the rule 1, we have to find out the longest chain of the carbon atom and we have to count the number of carbon atom. That is the first rule. If 5 carbon atoms are present, so 5 carbon atom means what's the root word of 5? Pent. So we got one answer, that is pent. Okay. Second one, we have to, as per rule 2, we have to identify, already I told you, we have to locate the bonds. If the carbon atom is connected by a single bond, then it will come alkane, that is saturated compound. If the carbon atom is connected by double bond, it is an unsaturated compound, alkene. If the carbon atom is connected by triple bond, then it is also an unsaturated compound, but it is a triple bond, so we have to use alkyne. Okay. See here all the carbon atoms are connected by a single bond only. Okay, all the carbon atoms are connected by a single bond. All the bonds between carbon atoms are single bond. Then suffix we have to use A. Okay, single bond means A, suffix we have to use. Just now I told you, isn't it? Single bond means A, double bond means E, triple bond means I. So here all the carbon atoms are connected by single bond, so suffix A has to be used. So second answer also we got. First answer is pent, second answer is A. Okay, we have to join this one. Got it? So the name of this compound is pentane. Got it, children? Name of this organic compound is pent. This is the first answer plus ane is the second answer. If you join this, you will get the IUPAC name pentane. Got it, children? So in this manner, we are going to solve some examples based on the rules, nomenclature. Okay, based on this, we have to name the compound. Okay, by using the IUPAC name. IUPAC means International Union of Pure and Applied Chemistry. Got it, children? Understood, everyone? Okay, what are the things we discussed today? Everything you go through. Read learn all the tabular column, root word, prefix, substituents, everything you learn. Okay, and formula also you should learn. The remaining things we will see in the next video. Thank you, children.